Hi, and welcome to my latest YouTube video. So in this video, I'm going to be talking about normality. So as you know, normality is very important if you want to perform parametric tests such as ANOVA or Pearson's correlation. Normality is in fact an assumption that the data is normally distributed so that these tests can be performed. Now sometimes normality is not achieved because there are certain outliers in your data. In this video, I'm going to be showing you how to identify those outliers, how to remove those outliers, and how to obtain normality of data so that you can perform parametric tests. So let's go ahead and do this. Okay, so here we have data regarding the depression, anxiety, and stress level of the respondents. So let's say I want to find out whether the anxiety level of the respondents is normally distributed. So there are two ways of finding out whether the data is normally distributed. One is to examining the skewness as well as the kurtosis values, which is the most common way of testing the normality. The other one is to look at the histogram. Of course, the histogram gives us a visual reference, but it's usually not enough to clearly state whether the data is normally distributed or not. We're going to be doing both. So let's go ahead and do that. We'll go to analyze. We go on to descriptive statistics. Click on descriptives. So I just want to put in anxiety. So total anxiety, I'll just pull it in here. I'll remove mean, standard deviation, minimum, maximum because I don't want to know any of those values. I just want skewness and kurtosis. So I check both of those and then I click on OK. So here I have the kurtosis as well as the skewness values as well as the standard errors. So now I need to divide the kurtosis value by its standard error and the skewness value by its standard error. And if the value exceeds 1.96 or minus 1.96, then we would say that the data is not normally distributed. So let's go ahead and test that. Let me open up my calculator. So the kurtosis value is 0.62. I divide that by the standard error, that is 0.48. I get the value 1.291. Now that's within the acceptable range, so that's not a problem. Let's go with the skewness values. The skewness values it's it's minus 0.69, and I divide that by the standard error, that is 0.24, and I get the value minus 2.875. Now this exceeds 1.96 or minus 1.96, so therefore this is not normally distributed. So there is a problem with skewness, and as you can see, it's negatively skewed. Okay, so we'll just go and check that out. We'll also do a graph, a histogram, to get an idea of how this looks. So click on graphs. We click on histogram. Now I just scroll down. I select the variable total anxiety. I pull it in. I click on display normal curve and then I click on OK. Now if you go back to our output, you can see that it is slightly negatively skewed because you can see this left side of the tail. It's kind of longish, and there is a negative skewness to this data. So we need to correct this negative skewness. We can try and correct it by identifying whether there are any outliers, and then we'll try to remove those outliers and see if the data is normalized. Okay, so how do we identify the outliers? So first of all, what are outliers? Outliers are extreme responses. These are responses that are very different from the rest of the responses, and this is probably because the respondent wasn't honest, maybe when they were responding, or maybe they didn't understand the question properly. So there are several reasons why we receive outliers, but they are usually extreme values, and because of these extreme values, our normal distribution of the data is affected. So therefore, we need to remove those outliers. So let's go ahead and do that. But as I told you, we need to first identify the outliers. So how do we do that? We go to File, we go to New, and then here we select Syntax. Here we type examine, click on Enter. Then we type variable. Now we click on the equal sign, and then we select the variable for which we need to test the outliers. So we just go to the variable view. So it's total anxiety 2, and we need to focus on the name that's been given there, that is TOTANX2. So TOTANX2, just go back here. I say TOTANX2. I click on enter, then I hit a slash, and I say plot, and then I put an equal symbol, and then I type box plot, boxplot. So this will give me a box plot which will tell me whether there are any outliers. So now I'm done with this. I'll just click on run and all. So once I'm done with that, I just go to the output. I scroll down. Now here you can see the box plot and you can see the outliers that are there. These are the case numbers 45, 59 and 61. They are outliers. Okay, they are extreme responses either on the very low end or the very high end. Actually this is the lower end, as you can see. It's, it starts from 0 here. So we need to remove these outliers if you want to get normal distribution. There could be some more below this as well. So once we clear this out, we'll know whether there are more outliers. So let's go ahead and do that. So the first variable that we need to remove is or the case that we need to remove is 45. So let's go and look at case number 45. We go to the data view for this. So here case number 45 is here. All right. So if you scroll to the right, you see that this respondent has given extreme responses, 0, like 0 everywhere. So there's something wrong with this, probably because the respondent didn't understand the question or they didn't want to give honest data. We don't know what the reason is. Either way, it's an outlier. So we click on this, right click on this, and then we clear case. Okay, so now we have done with that. Now the issue is that once we clear this 45, the 46th variable will become the 45th. So there's an interchange. So we need to test the box plot again to see if there are any changes in the numbers so that we don't delete the good data. So for this, again, we go to this syntax, we click on run again and all. So again, we go to the output. Now we see if there are any changes. Now as you can see, 59 has become 58 and 61 has become 60 because we deleted 45. So we need to delete these two as well. So the next one we're going to delete is 58. So let me go to 58 case, this one. So I just right click on this and then clear case. Again, I go to the syntax, I click on run and click on all. Just to be sure, I scroll down. I see another one which is 59. It's the last one. I hope so. Or maybe there could be one more below this. We don't know. So let's go ahead and do it. So this is 59 as you saw over here. So 59th response. I just scroll down. Yeah, so this is the one. So I right click on this. I click on clear cases. Now again I go to the syntax. I click on run to see if there are any more outliers, and as you can see there's one below it. So there's sometimes you can see once you clear up the ones that exist, you'll probably see one more below. So this is the 9th case. So we go to the data view, the data again, and the 9th case, I just right click on it and clear case. Again we go to the syntax, run and all, go to the output. Okay, so now we are in the clear. As you can see, there are no outliers here. So now we can go ahead and check for the normality. So let's go ahead and do that. So now let's go ahead and test the normality again of the variable. We go to analyze, descriptive statistics, descriptives. We already have the uncertainty variable in here because we had tested it earlier. We also have the skewness and the Curtis's value checked. We click on OK. We go to the output, and here you can see the skewness as well as the Curtis's values are here. This is a remarkable change compared to the one that we had earlier. You can see the Curtis's value here, okay, and the skewness values. So let me go ahead and check whether this is normally distributed or not. So how do I do that? Again, I open up my calculator. Yeah, and you can see the Curtis's value, which is minus 0.13. I divide that by the standard error, which is 0.49, and I get the value minus 0.58, which is well within 1.96 or minus 1.96. So that's okay. Let's look at skewness again, which was the problem last time. So this is minus 0.27, and we divide that by its standard error, which is 0.25, and then click on OK. So here we have finally received or obtained the normality. Here it's minus 1.66, which is within 1.96 or minus 1.96. Earlier, if you remember, the skewness value was close to minus 2.75 or something like that. So now it's much less. And again, we can again test this using the histogram. So let's go ahead and do that. We go to the data file, click on graphs. Yeah, click on histogram. Again, we have the variable in this inside as well, so we don't have to click anything. We just click on OK. Go to the output view, scroll down. Now you can see that the data is normally distributed. The left tail is now not too long, and it's kind of balanced on both sides. If you look at the previous histogram where it was skewed, you can see this longish left tail. But now if you scroll down, you check that the data is normally distributed. So now we have secured normality of data. We have confirmed it using the skewness and kurtosis value as well as the histogram with the normal curve that's over here. So that's about it for this video. I hope you found this video useful. Before I end this video, I just want to talk about 2 or 3 things with regard to removing the outliers. Removing outliers may not always work. Sometimes if you have too many outliers and if the data is already too skewed because of various other factors, then you can't do much. Maybe you will not be able to get normality of the data. And some variables are naturally skewed. Okay, for example, alcoholism. The data is naturally skewed in some case because there are only among all the drinkers, there are only few people who are heavy drinkers or heavy alcoholics. So in that case, the data will be skewed, and it's very difficult to identify and remove the outliers. And even if you do, you may not receive the normality of data. So these are cases where you have a few outliers, and if you remove them, you may get a normality. Also remember that removing of outliers is a luxury. You can usually do this only when you have a lot of cases, okay, like a lot of sample, because if you start to remove all of your cases, your sample size will decrease. So you need to ensure that you have a sufficient sample size to engage in this activity. So that's about it. Thank you for watching, and please like this video if you liked it, and subscribe to my channel for more such videos. Thanks for watching, and bye for now.